All right, so now we move into some grids. Okay, and I just want you to kind of take a look at the grid here, and you'll see here that with the original DDR, here I have a series of actual core RAM clock speeds, right? We had DDR 100, as far as 100 megahertz was the speed, all the way down through 300 megahertz. But you'll notice the actual DDR rating was double that, right? So if it was a 100 megahertz core RAM clock speed, the DDR rating, it was actually listed as DDR 200. All right, so if you ever see memory that's listed as DDR 200, you know that it's actually internally a 100 megahertz clock speed that's been doubled. Now from there, we have a PC speed rating. And what this PC speed rating has to do with is the actual amount of throughput. Okay, so what we're basically saying here is if we took that DDR 200 and then we go ahead and multiply that by 8 because that's the width of the DDR SD-RAM sticks. So you have the 200 megahertz, right, because that's the DDR 200, that's the speed rating. Multiplied by 8, you end up with PC 1600. And what the 1600 represents is megabytes per second. Okay, so that's the actual PC speed rating of how fast the data can travel. Now, this might seem like even the slowest one I have listed here, 1.6 gigabytes per second. Wow. You think about internet connectivity, getting 10 megabits, 20 megabits per second, or even how about networking, between computers? You're talking about, if you can get up to a gigabit of throughput per second, between computers, and that's lightning fast. Now imagine 1.6 gigabytes per second happening in memory. Well, remember, for all the data that you're trying to transfer back and forth between computers or out on the internet and this and that, remember how many millions of cycles actually take place inside the system and how much information, how much data needs to go through those cycles in order to actually get the output that you're looking at. Okay, so believe it or not, PC 1600 is not that fast. That's actually pretty much the slowest DDR speed that we're going to get. Okay, because the fastest DDR speed goes all the way up to PC 4800, which is 4.8 gigabytes per second. And again, you think that that would be, plenty fast enough. Getting almost 5 gigabytes per second is really fast. But believe it or not, it's not. Okay? So what they did was, again, through the use of these buffers and the lowering of power consumption, we moved into DDR2. So here's the deal. We start out with our core RAM clock speed of 100 megahertz, just like we had before. The DDR input-output speed is doubled, right? By definition, DDR doubles that, so now we have 200 megahertz. Through the use of these buffers, we essentially are able to double that yet again, and we now go to a DDR2 rating of DDR2 400. Multiply that by 8, you end up with a PC speed rating of PC2, right, to represent that it's DDR2, dash 3200, ranging all the way on up to PC2 8000. All right, so now we're talking about 8 gigabytes per second with DDR2. But because nothing is ever actually fast enough, we move on to DDR3. And with DDR3 and the advancements in that technology, you'll see here that we now can quadruple the clock speed. So essentially it should be QDR, right? Quadruple data rate. But anyway, DDR3, we're now quadrupling the actual I/O speed. And then through, again, the use of buffers and everything else, we can double it from there to give the DDR3 speed rating, where we end up with a 100 megahertz original core RAM clock speed, goes all the way up to a speed rating of DDR3-800. Multiply that by the 8 bytes again, and you end up with a PC speed rating of PC3-6400. And look at this. If you get a DDR3-2133, right, that's the chip that you would buy. You go out there and you get that chip. The actual PC speed rating is PC3-17000. Yes, that is 17 gigabytes per second. Is that fast enough for you? Anyway, I don't want you to get too caught up on these numbers. I just wanted to throw the charts up so that you have them. You may get tested on them. And even if you don't get tested on them, if you're ever out shopping for memory, now you have an idea of what these numbers actually mean. Also, keep in mind that when selecting memory for your computer, you can't just decide, oh, okay, this computer supports this one particular rating of memory chip. I'm going to go to a faster one because I want it to be faster. The motherboard and the processor and the memory, everything has to work together. So you need to look at the ratings of this stuff before you buy the computer altogether. Okay, because you can't just buy faster memory. It won't necessarily help you out if the rest of the computer is not designed to support it.